Welcome back. In this installment of section 4.4, the fundamental theorem of calculus, we're going to talk about displacement and distance traveled. And we started talking about this when we talked about a particle in motion. So, what is displacement and what is distance traveled? Well, if we think about displacement, and if we talk about a particle moving along the x-axis, remember here we had the x-axis, and we start anywhere, it doesn't matter, maybe time t equals 1, or time t equals 0, we're at position 1, and then maybe this particle moves to the right, and then it moves back, so we brought it up and we move it back to the left, and then we come back, and maybe we come back to the right. And maybe we end here, so maybe this is at time 4, to say. So what is our displacement and what is our distance traveled? Well, our displacement is from 1 to 4, so our displacement is 3. Our distance traveled, however, is going to take the entire distance of that path that we've gone. So it's going to take into account that positive motion as well as the negative motion and the positive. So how do we go about doing that with our integration? Remember, integration is an accumulation of something. In this case, it's going to be of distance. So our displacement, our net change in our position, again from that 1 to 4, that would be a net of 3. We're going to find that by simply taking the integration from a to b of our velocity function. And we've got to take it with the velocity function in order to be able to find that displacement. Our distance traveled, however, to get that length in there, we know we have positive and we have negative values in there. We want to make these negative values positive. How do we do that? Well, we can do that by taking the absolute value of that distance or that displacement there. So we can take from 1 to whatever this value is. Maybe it looks kind of like 2, I guess. And then maybe come back to 1.5, and then we work our way back. So our total distance is going to take the positive values of each of these distances. So we find that by taking the integration from a to b of our absolute value of velocity. And we'll talk about that here coming up and how we find that and how we can do that fairly easily. Or not necessarily easily, but how we can do it anyway. So given our velocity in feet per second of a particle moving along a line is v of t, blah, 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 where t is in time in seconds, find the displacement and the distance traveled. So we have a two-part question here. First thing is our displacement. So our displacement is going to be, again, the integration from 0 to 5. So we're going to go from 0 to 5. That's our time when we start 0 and we end at 5 of our function t to the third minus 10t squared plus 29t minus 20 dt. If this is an extended response question, we definitely have to set up the integration correctly. So the different parts of this, we definitely have to have our beginning and our end. So our end points for our integral. We have to have what we're going to integrate, or our integrin, and we have to have our variable of integration. We have to have that dt in order to get all of our points for this setup. So now we can go ahead and integrate this. And we can again do this by hand. We can do it by a calculator. I'm going to go ahead and throw it into my calculator just so we have it here. I'm going to go to my y equals. I'm going to go ahead and type in that function. So if x to the third again, we can use variable of x. We don't need that t since it is just a variable, plus our 29x minus our 20. And I put it into my y1. We haven't talked about this yet, but it's very useful for us to have it into y1. Why is that? Well, if I go ahead and quit out of this and get to my main screen, if I go to math and I can go to my finite, my integration, so math 9, I can integrate from 0 to 5, just like we would before. I could type this function in, my t to the third minus whatever we've got. Or we can recall this, since we already have it stored, we've stored it into y1. We know y1 equals all of this. So I can go, I'll come back out here. I can go to my vars, which is down here right below the arrow buttons, my directional buttons. I can go over to y vars, and I can go into function, and I can recall anything that I've put into my y equals. So I can use any of those. In this case, I have it in y1. So this is going to integrate from 0 to 5 that function I have in y1. Very useful as we get into our later chapters as we get into calculus. And I also have to put in my variable of integration. Remember, it was very important that we had it here. It's also important that we have it here, so our dx. And it's going to give me what my answer is. So my answer to this is 2.083. And that's going to be my distance that I've gone. So in this case, it's going to be feet if I want to know what my units are. Now, why is that useful as we look at our distance? So our displacement, I guess we should go ahead and list that. Displacement is 2.083 feet. So how do we come up with our distance that we've traveled? Well, we have to figure out where we have positive and negative values. So we're going to go ahead and graph this, and I'm going to graph it from 0 to 5 on my x-axis. And I'm really interested in where we cross the y, so I'm going to change those y's as well. So I'm going to go from, say, -1 to 6, just so I can see those x values at a scale of 1. And again, I'm interested in where we cross the x-axis, so I'm going to make the y's very small, maybe a -1 to 1 at a scale of 1. So if I go and graph this, notice we have a negative portion over here, we have a positive portion, and then we also have a negative portion. I'm interested in these zeros. Remember, for below the x-axis, we have to make that positive, so we're going to bring that up. So we have to integrate possibly 3 different regions, it looks like here. Maybe, depends, it looks like that's a 5, I'm guessing. So we're going to have to probably have 3 different integrations. So I'm going to go ahead and check, make sure my zeros are where I think they are. It looks like it's at 1 there. So I'm going to go left bound is 0, right bound at 2. So that does give me a 1. So for my distance traveled, I'm going to get the integration from 0 to 1 of the absolute value of that function. And I'm going to go ahead and put it in as v of t because I'm kind of lazy and I don't want to type it all out. To that, I'm going to add the integration. Again, it looks like we got, what, 2, 3, it looks like we're at 4. So again, I'm going to test that, double check it. Always double check to make sure your zeros are actually what they are, because we do kind of like to mess with you and maybe put it at 4.01, which would cause you to be a little off there. So then we're going from from 1 to 4 of, here we don't need the absolute value because we're always going to be positive there. So it's just, we can put v of t, or we can put in the absolute value of v of t. Doesn't matter. Again, we should put our variable of integration in there, dt. And then plus, it looks like we're going to 5 there. So I'm going to go ahead and calculate that, 0. We're going to go 4.5 to 5.5, guessing 5. Yep, so we have the integration from 4 to 5. Again, that's below the x-axis. So we want to flip that up, so we're going to take the absolute value of that. So the absolute value of the velocity, dt. So that would be kind of ugly to do all by hand, wouldn't it? So what we can do in our calculator, we can go into our math, we can go into 9, and we can set this up. So here we're going 0 to 1, so 0 to 1 of v of t. And again, remember, v of t is going to be what our y1 was. So we can go into our vars, y vars function 1 dx. But we need the absolute value in there. I forgot the absolute value, so we can go and insert my absolute value. So math, go over to num, my absolute value. And then I guess I need to recall my y1, don't I? So y vars function and y1. Go ahead and delete this other one we've got. So notice now I'm going from 0 to 1 of the absolute value of y1 dx. To that, I'm going to add the integration, so another math 9. The integration from 1 now to 4 of the function. Again, remember, that was above it. But if we want to put in the absolute value, it makes life a lot easier, I think. We don't have to think about if it's positive or if it's a negative value. So I'm going to go ahead and recall my absolute value. And I'm going to recall my vars, y1. And again, we're in variable of dx, or variable of x. And then to that, I'm going to add the integration, so math 9 the integration from 4 to 5 of my function. Again, I'm going to do my absolute value, go over to num, absolute value of vars, y vars function, and y1. And again, go and put in our variable of integration, dx. And hit enter. We get a total value of 20.416, or if you want 20.417 feet. And that's going to be our distance that we travel. So that kind of gives you an idea of using that calculator to your advantage, especially if we can put it into our y equals and be able to come up with those values. All right. The next problem I have is we have a particle that moves along the x-axis, the position function, or the position of the particle is given by the function t minus 1 times the quantity of t minus 3 squared. And we're going again from 0 to 5 in this case, and how find the total distance that we've traveled in 5 units. So we don't necessarily need the displacement this time. We're just looking for the distance that we've traveled in that 5 units. So the first thing, again, remember we're going to integrate the velocity, so the absolute value of the velocity. So in order to get that velocity, we're going to find the derivative of this function. This is our position. To get the velocity, we got to find the derivative of that. So a couple ways you can do that. You can go ahead and multiply this out, and then go ahead and find the derivative, or you can use your product rule. It doesn't matter to me how you want to do it. Let's just get it done. So I'm going to go ahead and use my product rule. So we have t minus 1 times 2, t minus 3 to the first times 1, and to that we have t minus 3 squared times 1. Looks like we have a t squared minus 4t plus 3 times 2. I multiply my t minus 1 to my t minus 3. And to that I have t minus 3 squared, which is t squared minus 6t plus 9. So it looks like I've got 2t squared minus 8t plus 6. And bringing in my rest of it. Go ahead and add like terms. I get 3t squared minus 14t plus a 15. So again, I'm going to go ahead and put that in my calculator. Put it over here so you can kind of see it there. I'm going to move that over so I can see as well. So again, I'm going to go to my y equals. I'm going to go ahead and clear that out. I'm going to go 3x squared minus my 14x plus 15. And I'm going to go ahead and graph it since I've already got that where we were. So notice here we have an area above, we have an area below, and then another area above the x-axis. And they like to do this with us. So we're going to integrate, looks like from 0 to what this value here is. So what is that value? I'm going to go ahead and calculate my 0. Looks like we're between 1 and 2. And we're at 1.6666667. So I know that's 1 and 2/3. So we can go ahead and do 5/3 if you want. If this was a nasty value, we could store this. And I want to go ahead and show you how to do that because it's very useful as, again, we get into our later units. So I'm going to go ahead and quit out of this real quick, go to my main screen, and I'm going to hit store. Remember, store is right above the on button, and I'm going to go ahead and store it into A. And that's going to take that X value and store it in to A. So in here, I'm going to go ahead and take that 5/3 and also make that equal to A, so I can recall that A in my integration. So again, we're doing absolute value. We don't necessarily need the absolute value symbols again because it was above the x-axis, so we know we're moving to the right. However, to make it easy and less complicated, I think if we always take the absolute value of the velocity, it makes your life a little easier. A little more typing, but we're good with that. So then we're going to go integration from A to that we're going to add. Again, we're going to go back to our zeros. And we'll continue on our path here. It looks like it's about 3. So I'm going to go 2 to maybe 4. And it does end up at 3. And then again, my absolute value of the velocity function, dt. And then to that, I guess I'm running out of little room. I'm going to integrate from 3 to 5 of, again, the absolute value of the velocity again. I don't have to have the absolute value on this one because we're above the x-axis. However, it's useful to make our life a little easier. So I'm going to go ahead and quit out of that. I'm going to go to math. I'm going to go ahead and just go through the motion here. So Again, I can type in 5/3, or I can do my alpha A, and that's going to bring my A value. Again, I'm going to do the absolute value over there of my function. So I'm going to go vars, y vars, function, and y1. Come on over here. Oh, hit the wrong button. That's all right. Dx. To that, we're going to add from a to 3, the integration. So math 9, integration a to 3 of our velocity function, absolute value again. So math 9. And I'm guessing as I'm going through this, some of you are probably asking, well, why can't I just take the opposite of it? Why can't I just take the negative of it? And absolutely, you probably can, as long as, again, you keep that straight in your mind. Doing the absolute values kind of keeps that straight in your mind, because you always know distance, I had to take the absolute value of all those values. So they're always going to be positive. And then to that, I'm going to add math 9, another integration, this time from 3 to 5. And then of our absolute value, so math, not a double integration. Delete that. So we're going to go to math over the num, and then our vars, y vars function, y1, dx. And hit enter, and voila! We end up with a value of 27.370. And our units in this case, it doesn't give us our units. Oh, how sad. Say maybe we'll do this in feet for this case. All right, so that gives you an idea of where you're going to see the difference between displacement and distance, as well as how to use that calculator and some of those functions that we've used before to make your life a little easier. Good luck, enjoy, and happy integrating.